Okay, in this next video we're going to look at solving trig equations with radians. So our first is solve 2 cos 3x plus 1 equals 0. Our cue that this is radians is that our range is between 0 and 2 pi. So rearranging the equation, we get cos 3x equals minus a half. Now if we sketch our cast diagram just to establish which quadrants this lies in, you can see our cast diagram is slightly different. We have 0, pi over 2 pi, 3 pi over 2 and 2 pi. Cosine is negative in quadrants 2 and 3. In quadrant 2, to get the angle you subtract from pi as opposed to 180, and in quadrant 3 you add 2 pi as opposed to adding to 180. As always, when the ratio is negative we solve for the positive, so cos 3x equals a half. Looking at our exact value triangle, the angle that gives us an adjacent of 1 and a hypotenuse of 2 is pi over 3. So 3x equals pi over 3. This is not our correct solution, so we're going to discard that but use it to get our actual answer, our actual solutions. So 3x is in fact equal to pi minus pi over 3 and pi plus pi over 3. Which gives us 2 pi over 3 and 4 pi over 3. The 3 in front of the x indicates that we will have 3 waves within a 2 pi range. So we have to have 6 solutions as opposed to 2 solutions. So I'm going to just add 2 pi onto my first 2 answers and then add 4 pi onto my first 2 answers to get all 6 solutions. 2 pi, if you think, is just the same as 6 pi over 3. And 4 pi is equal to 12 pi over 3. So if we do that addition, we get 2 pi over 3, 4 pi over 3, 8 pi over 3, 12 pi over 3, and then adding 12 pi over 3 onto 2 pi over 3, we get 14 pi over 3 and 16 pi over 3. All that remains to be done now is to divide by 3, so the denominators will become 9 in each case. And then simplify any fractions where possible. Okay, next up we're going to solve 2 cos squared x equals 1, where x is between 0 and 2 pi. So again, we know we're now working in radians. Rearranging the equation, we have cos squared x equals a half. So cos x is equal to plus or minus 1 over root 2. So if we split the equation into 2, so cos x equals 1 over root 2 and cos x equals minus 1 over root 2. Again, in our cast diagram, cosine is positive in quadrants 1 and 4. So drawing our exact value triangle, the angle that has an adjacent of 1 and a hypotenuse of root 2 is pi over 4. So x is pi over 4 and 2 pi minus pi over 4, which gives us pi over 4 and 7 pi over 4. cosine is negative in quadrants 2 and 3. Again, so that'll be pi plus pi over 4 and pi minus pi over 4, which gives me 3 pi over 4 and 5 pi over 4. So there are 4 solutions here. Finally, solve 2 sine brackets 2x minus pi over 3 equals 1. Please note that we're only looking at x between 0 and pi here, so we need to be careful with our solution set. So rearranging the equation, we get sine bracket 2x minus pi over 3 equals a half. Sketching our cast diagram, sine is positive in quadrants 1 and 3. Using our exact value triangles, which angle has a sine, an opposite of 1 and a hypotenuse of 2, that would be pi over 6 radians. So 2x minus pi over 3 is equal to pi over 6, and pi minus pi over 6, which is 5 pi over 6. Now I'm going to add the pi over 3 onto each, which is the same as 2 pi over 6, so that gives me pi over 6 plus pi over 3, 5 pi over 6 plus pi over 3, so 2x is equal to 3 pi over 6 plus 7 pi over 6. Again, the 2 in front of the x indicates that we'll have 2 waves within 0 and 2 pi. I'm just going to add 2 pi onto each of my solutions, i.e. 12 pi over 6. I'm just doing this just to make sure I get all the values. So that gives me 2x is equal to pi over 2, i.e. 3 pi over 6, 7 pi over 6, 15 pi over 6, and 19 pi over 6. Finally, all I need to do is divide every answer by 2, so that gives me pi over 4, 7 pi over 12, 15 pi over 12, and 19 pi over 12. The last 2 solutions exceed pi, so they should be discarded. So my solution is